working on this little baby Manitowoc here, and I'm not liking how long it's taken to form the ice. And then this can be tricky to do in such a tight cabinet, but as the top of this compressor is barely warm, I think it's low on charge. If I could, I'd feel the discharge and suction lines. This is a processed stuff here, which I'll braze a tap onto if I need to. I had mentioned that my gut feeling was just that it was taking too long to harvest, and that is certainly correct here. This is going to be my longest harvest time. This would be at 100 degrees ambient with 90-degree water. But see, I'm more like up in here. Now, this machine's been running. I started it up and, you know, just let it run. So I've got at least 45 minutes, I think, on that cycle. Well, I did get a harvest out of it, so I think I'm gonna give it a cleaning. And someone already tried to clean this condenser, but you can see that crud's down in there pretty deep, so I'm gonna blow it out. Clean the machine and just let it run and see how it does. I'm gonna clean that sensor too. See, this here is the harvest sensor. It's one of them. This is the other one. This will log a dump, and then this will tell the circuit board when the ice is thick enough to harvest. If you look, yeah, it's kind of nasty. All right, just clean that up with the driller pad. Looks nice and fresh. Got my nitrogen tank here on the cart. If you haven't made yourself one of these, I highly recommend it. I just soldered this one. All this is a quarter flare to an air chuck. I mean, you can use fittings, you don't have to solder it. Put that on there, use my air hose and that long thing so I can get out of the dust cloud, you know what I'm saying? This ice machine here doesn't have a drain hole, so I'm gonna make something. Let me show you something. You know, when you're an apprentice and cutting the end off a copper pipe, a lot of times you're kind of just going slow. But really, when you're cutting the end off, just get used to doing it in a solid motion. Every time I go around, I'm turning it a little bit just with a light-handed grip. So that's a lot faster there. It's one of my favorite benders. Using a unibit to deburr things. It's really nice. Okay, right about there. See how nice that works to drain the bin. Now it will drain the bin as part of the cleaning cycle, but this is nice because I'm getting fresh water in, wastewater out. getting a nice water change on that whole system. It's also giving me a way to melt this ice out when I was testing it. Well, let her run overnight, actually 2 nights. She's locked out on a code there. Well, it's not a code, which is kind of a pain. It's just a flashing LED, so I don't believe this unit has codes. Now, yes, could you pull this and like do a full diagnostic on it? Of course, but sometimes it can be a cheaper, easier, quicker diagnostic practice just to throw a charge in it and see what happens. That's a valid way of diagnosing, you know, such a little appliance where everything's hard to get to. Time to put a tab on this process stub. Now, you don't need brazing for this. In general, there's a lot of things that we could do without brazing. Why do I need to braze in this little cabinet with all that heat? That's all you need right there. And I'm gonna be using this, the name of this escapes me. Tinning flux, that's what it is, because it's got solder chunks in it. And so when this flux flows, it actually puts down a coating of solder. I just really like it. Now, I didn't deburr that because why do I need to do that? See, there's a lip in there already, and I'm not gonna send chunks down into that compressor. For cleaning copper, nothing works better than a Brillo pad, unless it's real dirty. Okay, I'm also gonna rip a little chunk off of here and shove it in there. Clean up the inside surface of this. That. Now, when you're dealing with small stuff and soldering on an HVAC system, better to flux the pole and not the hole. Always remember that. But you do need to run this around and make sure that we got a good layer in there. I also like having a little bit of flux up here because if this surface oxidizes, it'll tend to resist the pull of solder into the joint, even if the joint is fluxed well. I've got a video on this little beauty here. Oh yeah. But this is what I'm gonna be using. Notice I'm putting most of the heat into the fitting because that's the thickest part. Hey, how are you? Stressful day, huh? All right. One of those days, huh? Monday on a Thursday, huh? I hear you. One thing I like to do, let's take a look at this joint real quick. Yeah, perfect. One thing I like to do is leave both of these connections loose because you don't want your hose putting a lot of pressure on this process stub right here. I get them hooked up and tighten them. I'm about to turn this unit inside out and suck it into another dimension. All right, she's in a deep vacuum now. Passed an isolation test. So if it does have a leak, it's a small one. The thing is, you know, it could be a metering device issue. It could be, we could have a hot gas bypass valve leaking by a little bit, but I'm just going to do this and see what happens. If this doesn't work, the thing is we're probably just going to rip this out and put in a new one there's a point to where it's just not worth it. We have better things to do. So that's kind of the plan on this. But I'll do whatever they want. If they want me to rip it completely apart and try to diagnose it, I'll do that. No problem. Now, you don't need a big manifold when dealing with something like this. You know, my preferred method is just to pull a vacuum on the hose, and then I'm going to weigh in exactly what it takes, which is a ½ pound. And once I hit that ½ pound mark, I'm going to shut that valve off, which is going to be at the tank, and then start the unit up and make sure there's no liquid hanging out this valve, so I get exactly ½ pound. I'm at like 15 psi, which I don't know what this should run, but that's about right. With 134A, the temperature and pressure correlate pretty well, so that's going to be close to 15, which should be good on this plate. I'm already getting more ice than it was before. We're only 7 minutes in, and that's 7 minutes from a fresh charge, so you know, I'm going to let this harvest and then probably log the next one and see where we're at. Down to 10 psi now. Top of the compressor's a lot warmer. Our ice is looking better. I adjusted that a little bit because I didn't want it to give a false signal. These ice cubes will be a little thicker, might take a little longer, but they're looking pretty good there time-wise. You might be able to hear that hot gas bypass valve heating up this plate now. That's looking good. Great time-wise. Now, if you're interested in how this works, this is just a logic voltage that gets pulled to ground through the water. So I'm reading 2.6, that was the ice there. I'm reading 2.6 volts. This is probably a 3.3 volt signal that my meter's actually pulling down a bit as I'm taking the measurement. But that's how it knows that the water, i.e. the ice, is getting built out to a point where it needs to harvest. And then when it does this, when it drops, it knows it's dropped by this registering as well. I've never worked on this unit before, so I'm not sure, but I believe. So it knows when this ice dumps via this, but also once the ice builds up, this is going to stop pulling away and quit activating that read switch in there. So it's also going to know via this that the bin is full. I'm going to play around with this a little more. So I've got this logic voltage on this paddle, but if connects to ground, that voltage gets pulled down and the IC no longer sees it. This light comes on. When that voltage comes back, that light is off. Just went into harvest at 18 minutes. Yeah, you can see where that hot gas valve opened back up. Yes, yes. All right. She's working. Well, she shut down again for some reason, so this is kind of like a part 2. And I did some digging and finally found how to maybe pull a code out of this thing. So apparently if I turn it off, then back on, those 2 flashes correspond to safety limit 2. I think there's only 2 safeties that can cut this thing off. I wonder what they are. Yeah, I messed that one up, so you know, and just not having the service information was a problem, but with this green light on all the time, which is the bin switch light, it would have indicated that the bin switch was not changing states. I should have seen that light change, and I did not, because it shorted out. To whereas if it was acting right and that bin switch was opening and closing as it should, I'd see that green light flicker. And that was my bad. I assumed that green light was just a, you know, like your typical green light on on a circuit board, just indicating that it's on. It's got power doing its thing. Okay, well, at least I got to show some different stuff, even though it was the wrong stuff. The wrong time for the right stuff. Little reed switch up in there is probably bad. All right, here it is, little potted reed switch, and banging it like that just freed it up. See, this is a magnet on here. Basically, the way a reed switch works is it's two little thin pieces of metal in there, and the magnet pulls them together and closes the contact. They're more like end to end, not side by side, but you get what I'm saying. Okay. Well, you got it. Yeah, I just don't work on a lot of ice machines, so it threw me off. Maybe all Manitowocs are this way, and I should have known from the start, but that's just how it goes sometimes. I like to show these videos too, because, you know, people get the impression that I get everything right the first time sometimes, and that, you know, that's just the YouTube phenomenon there. Nobody's like that, so this was my mistake. Look at that nice tap though. Ooh, yeah, she's gonna be ready to roll when I need to check pressures. Doing stuff in-house, it's not as big of a deal, which is why I just threw a charge in there. If this was for a customer or something, that's probably not something I would have done. All right, I think we got it. Well, it's those little units that kick my butt the hardest sometimes. But anyways, wanted to do a recap because things got a little crazy. I think I pieced together everything well, but one thing I didn't catch is I was activating that bin switch in the beginning, and I saw it correlate exactly with that red LED. And so I thought that the board was getting that signal, but I guess it was just water splashing on that sensor or something that was causing it to flicker at that time. So anyways, that's what led me down kind of like a rabbit trail, and I had the manual, but it was like 250 pages, and I looked in there and I just couldn't find any information on those LEDs. And typically when you have a green LED on a board, standard design is that green LED, especially if it's constant, indicates power to the board. And so if I were to redesign that board, I would have a green and two reds, so power, and then two reds to monitor the switches. It's very strange. It's also strange that it's convoluted to pull a code out of that board. Like, why flash it continuously? Just do that double flash, and there you go. There's your code. So I don't know. I kind of like Manitowocs. I don't work on a lot of ice machines, but I like them. You know, I'm not trying to throw them under the bus, but that's how all of that happened. Thanks for watching. I keep forgetting to put like and subscribe at the end of videos, so please do that. Smash that like button. It really helps the channel out. Also, I have Amazon links. That's another great way to support the channel. If you like any of the tools that I showed, they'll be down there in the description. Thank you, and I'll see you in the next one.